All right, so new probability notes for week 2 of online learning due to the coronavirus, of course. So, first, before I get into some new content, I want to quickly review some of the definitions and notations for last week's content. You should definitely have, and I'm going to upload these notes as a PDF to It's Learning. You should definitely have these notes by your side. Um, this can get tricky if you try to memorize everything in your head, but if you use these notes as a reference, it will make your life much, much easier. All right. So first, a review of last week's stuff. First, N of E. So E is going to be some event. So the event can be a possible outcome. If your experiment is rolling 2 dice, maybe an event is you get double threes. So this N just means the number of. So this N of E is the number of outcomes in event E. N of S is just going to be the number of total possible outcomes. S is for sample space, which means all possible outcomes. So N of S is the number of total possible outcomes. Okay. Now those two go directly into the probability of event E happening. And that is equal to the number of outcomes in the event divided by the total possible number of all outcomes. So P of E, the probability of event E, that is just going to be the total number of things in the event divided by the total number of all possible outcomes. So if it's, for example, the probability of flipping a coin heads, okay, a coin has 2 possible outcomes, heads and tails. And one of those is heads. All right, not answering that. Sorry, friends. So the possibility of flipping heads is 1/2. And again, the number of total possible outcomes when you flip a coin is 2, heads or tails. One of them is heads, so number in the event 1, total possible 2, 1/2. All right. The next is union and intersection. It almost looks like a capital U, but there's no tail on it. This is the union symbol, and that is associated with the word or. This means if I were to see A union B, this means things that are in event A or in event B, or both. Intersection. This is the upside down union symbol. This is going to be associated with the word and. So if I see A intersect B, this is only things that are in A and B. So quick little Venn diagram. If I see the union, that's all the things that are in event A, and all of the things that are in B. It's actually an or, sorry. Or the things that are in both of them together. But if I see A intersect B, here I'm not concerned with the parts that are in A and not the parts that are in B. This is just the and, just this little guy right here, that it's in both. So in general, unions are bigger than intersections. Intersections don't have everything. Intersections are just what two things have in common. Union is or, everything in A or everything in B. Intersection is and, everything that's in A and in B. All right, and lastly, independent. In general, things that don't depend on each other. And we have a math equation for that. If A and B are independent, then the probability of A times the probability of B will equal the probability of A intersect B. So only if they are independent. All right, so that is a quick review of last week's content. I will upload this into It's Learning. Let's take a look at some new stuff. Just judging on how far along this video is, I'll probably break this into two videos, part 1 and part 2. Okay, so first is complements. Complements are when two different events that have nothing in common add together to be 100%. So two events with nothing in common add to 100%. And we have a little symbol. Because there are two events, they have nothing in common and they add to 100%. You either have an event or not some event. So A is going to be event A. Not A is not in event A. And the probability of these two events happening together should add up to 100%. And that's, again, only if the two events have nothing in common and they add up to 100%. So this actually sounds a little more complicated than it is. This is way easier than I'm making it sound. It basically goes like this. If either something is going to happen or it's not, and there's no other option, it either happens or it doesn't, then the probability of an event happening and the probability of it not happening should add up to 100%. So here's a super quick example, two of them actually, and they're fairly easy to get. This idea of complements is pretty easy. If there's a 30% chance of rain, what is the chance of no rain? So it either rains or it doesn't. There is no third option here. So 30% chance of rain should add up with the percent chance of no rain to equal 100%. So let's say R equals the event rain, right? Probability of R plus probability of not R should add up to 100%. Now, I've told you in the problem that the probability of it raining is 30%. So 30% plus the probability of no rain equals 100%. Subtract 30% from both sides. And the probability of no rain is 70%. Because, yes, the two events have nothing in common, okay? It's not raining and not raining at the same time. It's either one or the other. And then the two of them add together to be 100%. So basically, we just take 100% and subtract the probability of the thing we know, right? So let's say in my next example here, where I'm just playing some game, and I were to tell you there's an 11% chance of getting a 17 on the next play of whatever game we're playing. What is the percent chance of not getting a 17 on the next play? It's literally 100% minus 11%, or 89%. We'll just quickly work that out. So let's say probability of getting 11 is set 11%. I'm sorry. The probability of getting 17 is an 11%. The probability of not getting 17 is going to be 100% minus the 11%. That's where we get our 89% chance from. So complements is super duper easy. It's either something happens or it doesn't, and those two probabilities add up to 100%. So if you know the probability of something happening, 100% minus that probability is exactly the probability of that thing not happening. It sounds really easy and simple, but this is actually a very powerful counting technique. All right. I think I'm going to break this video here into two parts, and we'll take a look at part two in a second, where we look at conditional probability and some more counting techniques. I'll get those notes ready to go in a second.